Another thing where it is dependent upon is the time of action. The time of action. For example, you might have observed while playing cricket, the people among you who have played cricket for a long time or even for some period of time, they might be well experienced about this very fact that upon catching a ball, if you are trying to catch it, if you make your these hands stiff, the ball which is coming down will exert some force on your hands, and you will feel more pain on your hands, because the time of action is very, very small. Okay, now the experienced and the professional cricketers, what they do when the ball is coming down, they try to push their hands back. Okay, they try to increase the time of action of change in the momentum, because the ball is possessing some momentum. It is moving with velocity something. It's possessing some mass, so it possesses what? Momentum. Because momentum, I told you, is product of mass and velocity. So, but the time of action here is very much greater as compared to the first case. So that means in this case, the force is also exerted, but the time of action has got increased, and we feel lesser pain or negligible. That means force exerted in this case will be very, very small, because the time of action is increased. So that means another experiment, we can say from this experiment, we can say if this is the time of action of the of any, we can say if the ball is coming down towards your hands and you increase the time of action from this point to this, say 2 seconds. By 2 seconds you increase the time of action. So in that case, force will be lesser. Force exerted will be lesser. Why? Because the time of action is decreased. In that case, in the first case, if you will make on the first instant without changing the time of action, you will feel more force. That means the change in the momentum also depends upon how faster the action is going on. So momentum change, we can say that the greater the rate of change of momentum, greater will be the what? Greater is the force. Okay, greater is the, if the change of momentum takes place and the change in the momentum, the rate of change in the momentum is very much greater, that means time of action is very much smaller. Okay, this momentum, for example, the ball possesses, on the first instant the ball possesses some momentum mv, and when it comes to rest in your hands, it possesses zero momentum. Okay, the two, first it possesses, the ball is coming down, it possesses momentum mv, let's say p. But if the time of action is smaller, instant, so change in the momentum will be rapid. That means we have put our hands stick to one position only. Well, these are stuck to one position only. So in that case, the rate of change of momentum will be greater. That means force exerted by the ball will be more. But if we change the time of action to this very position, so that means time is given to pick up the ball, we push our hands back, so in that case there is a kind of relaxation time. So in that case, the time of action will increase. Okay, time of action will be increased, and the rate of change of momentum will be lesser, because with the passage of time, it will slightly decrease, and then ultimately decrease. Here its rate of change is rapid, but here the change is not so much rapid. So that means if the rate of change of momentum is not much rapid, that means the lesser force, and if the greater rate of change of the momentum is there, that means the force will be greater. Okay, so we can sum up this as the greater the rate of change of the momentum, the greater will be the force, and if the rate of change of the momentum is smaller, that means we are providing now the relaxation time of action is increased. In that case, lesser force will be exerted. So force also depends upon the momentum change, but not only the momentum change, but on its rate of change. So time factor comes in. Okay, this is very much important. That time factor matters here. That time of action, if time of action is increased, in that case force will be felt smaller. That will be the change in the momentum takes place in a much greater time. That means the force will be exerted lesser. But if the greater the momentum change, if the change in the momentum is greater in lesser time, that is the rate of change of momentum is more greater, in that case force will be experienced very much high. Okay, so we can further say that I can say the momentum now from all these observations, these are all experimental facts which we observe in day-to-day life from observation. Okay, what does observation confirm? It's actually the product of mass and velocity which matters. Actually, mass and velocity is the basic component to affect the force of a body which is moving, or which is at rest. That depends upon this case. So for any body, the force is determined by actually the mass and the velocity of that. It is not only the mass, it's the product of these two. So it depends upon that. Not exact the force is equal to the product of these two, no. But it depends upon the rate of change in the momentum. Okay, rate of change in the momentum. We have observed here, if more relaxation time is provided, that means time of action is more, then the force will be felt lesser. We will not feel so much pain in our hands. And if we put our hands stiff, if these are stiff, then in that case time of action will be very, very small, and in that case the rate of change of the momentum will be lesser. That means the force will be okay. Now